In this video, we're going to focus on proving this formula. We're going to prove it in 4 different ways, and we'll start from my favorite one, the one that uses the dot product of two vectors. Let me remind you that by definition, the dot product of two vectors is the product of their lengths multiplied by the cosine of the angle between these vectors. And we also have a Cartesian formula for that product. If two vectors have coordinates x1, y1 and x2, y2, then the dot product of these vectors is x1 times x2 plus y1 times y2. So we will use that identity to prove the formula. And to do that, let's draw a unit circle, cosine axis and the sine axis. And let's consider two angles. This one is going to be equal to alpha and this one is beta. If we consider these two radiuses as vectors, we know that their magnitude equals 1 since this is a unit circle, and we can also obtain their coordinates just from the definition of cosine and sine of a number on a unit circle. Obviously, this angle between the vectors equals alpha minus beta, so for the left-hand side of this equation, we will have 1 times cosine of alpha minus beta. And for the right-hand side, we will have x1 times x2, or cosine alpha times cosine beta, plus y1 times y2, or sine alpha times sine beta. And thus we have our formula. This, once again, is my favorite way of proving the formula because it is the most elegant and it doesn't require that much evaluations. So let's focus on the second technique of proving that formula. And we're going to use the formula for the distance between 2 points. The configuration is the same as in the previous method. We're going to think about angles alpha and beta as of some angles on a unit circle. So let's consider these 2 points. We know their coordinates and let's find the distance between them. I'm going to write down the square of this distance, and by Pythagoras theorem it is equal to cosine alpha minus cosine beta squared plus the same thing for sines. And if we now open the parentheses, then we will have cosine squared minus 2 cosine cosine plus cosine squared, and something similar for the sines. This is equal to 1 and this is also equal to 1. So we're gonna have 2 minus 2 times cosine cosine minus 2 times sine sine. Now the other way to express the square of this distance is to use cosine rule in this triangle. So by cosine rule, d squared equals 1 plus 1 because these two sides are equal to 1 because this is a unit circle. Minus 2 times 1 times 1 times cosine of an angle between these two sides. So it's cosine of alpha minus beta. So we have 2 minus 2 cosine of alpha minus beta. And since these two expressions are equal to each other, we can state that minus 2 cosine of alpha minus beta equals minus 2 cosine cosine minus 2 sine sine. And these two terms cancel each other. So if we just divide both sides of this identity by minus 2, we will have the formula for cosine of alpha minus beta, which of course looks exactly the same. Now the third way of proving this formula is actually to prove another formula. We will prove sine of a sum of two angles using areas. Let's consider these angles alpha and beta as two acute angles in different right-angled triangles with an adjacent leg 1. We can say that this hypotenuse equals 1 divided by cosine alpha, and similarly this hypotenuse is 1 divided by cosine beta. Now if we join these triangles together to form a bigger triangle with an angle alpha plus beta, then the area of this triangle is 1/2 of product of two sides multiplied by the sine of an angle between these sides. So it's 1/2 multiplied by 1 over cosine of alpha times 1 over cosine of beta times sine of alpha plus beta. On the other hand, the very same area is 1/2 of a product of these two sides multiplied by the sine of an angle between them, or the area of this triangle plus the area of this triangle. So it's 1/2 times 1 over cosine alpha times 1 times sine alpha plus 1/2 times 1 over cosine beta, or this side by sine beta. So we multiply that by 1 by sine beta, and this is the same area. So we have an identity. And if we divide both sides of this identity by 1/2 and multiply it by the product of cosine alpha and cosine beta, then we will have sine alpha plus beta equals sine alpha times cosine beta, because we have got 1 when we multiply this by cosine alpha, plus cosine alpha, this time cosine beta and 1 over cosine beta give us 1, multiplied by sine beta. Thus we have sine over sum formula. And in order to get this from that, we just need to use trigonometric identity for cofunctions. So cosine alpha minus beta equals sine pi over 2 minus alpha minus beta, or sine of pi over 2 minus alpha plus beta. And now we have sine over sum of two angles. And if we use this formula, we will get this. Right, so let's talk about our fourth technique of proving this formula. And this time we will again prove sine of a sum formula. But now we will use Ptolemy's theorem. Let me remind you that Ptolemy's theorem states that for a cyclic quadrilateral, the product of its diagonals equals the sum of products of its opposite sides. So this identity is true. Now we have to consider angles alpha and beta as two angles between sides and a diagonal of a quadrilateral. And this quadrilateral is cyclic, and the diameter of a circumscribed circle should be equal to 1. Now we understand that in that situation, these angles are right. So by definition, this side of a quadrilateral equals sine alpha, and this side of a quadrilateral equals cosine alpha, and here we have got cosine beta, and this side is sine beta. The only thing left to do is to find another diagonal of a quadrilateral, and if we look at it as the side opposite to angle alpha plus beta in this triangle, then by sine law its length is sine of alpha plus beta. Now if we use Ptolemy's, the product of the diagonals, or sine of alpha plus beta times 1, or just the sine, equals the sum of the products of these opposite sides, the product of these opposite sides, so it's sine alpha times cosine beta, and the product of these opposite sides. So it's cosine alpha times sine beta. And thus we again have sine over sum formula, and now we can prove our original formula. And that is all for the 4 methods of proving the formula. If you know another interesting techniques, please write them down in the comment section. And thank you for watching this video. I hope you enjoyed it. I hope you learned something new. See you in the next one.